commercial product. So if you're looking for that level of detail, you won't find it here. But I will at least address how to get started in that space, because it is a weird foreign space, especially if you're not an electrical engineer. I am not. My undergraduate degree is computer information systems, and then I went on to do a master's in education and then another master's in CIS. So I always had just kind of I admired the knowledge levels that the system admin had when I was an undergrad, and he would take me aside and show me some things. It's like the 3 greatest commands if you want to know anything about systems administration are grep, set, and awk. I'll say that for everyone's benefit, because those are super powerful commands. And I know that the terminal shell doesn't seem like all that exciting or fun or impressive, but that's where all the work gets done, right? As you're going to find out as you go on in your career. So anyway, what led me to building this thing was the fact that I was freelancing prior to my arrival here at YSU, and I had a lot of big data projects. I had one project that I had to, I used AWS instances to accumulate 6.5 million public records and perform geocoding, geospatial query in real time. So like when you go to Google Maps and it uses your location data, for instance, and it puts you in the center of the map, and then it populates map pins around you, like show me all the restaurants near me. So that kind of query. So big data, big queries, that was done in Couchbase with NoSQL. If you've never seen non-relational databases before, Couchbase is a really interesting and cool thing that you can get into. And it's also a good introduction and gateway into writing queries that are MapReduce based instead of SQL based. How many people have database experience? Anybody? Useful, super useful. So learning to write SQL, especially like when you use like a local flat file prototyping database like SQLite, super easy to maintain, super easy to prototype minimum viable products with. But when you want to grow to scale, you've got to start looking at, okay, well MySQL can get you so far, and then you have to start sharding the database because there's just too many users, too many records, and it starts to get cumbersome. So Couchbase is like a document-oriented database, and I really wanted to be to the previous slide. So this is just all backgrounder stuff about how I arrived here, because everybody gets here in a different way, I think, and a lot of electrical engineers just kind of, this is their native habitat. But not at all for me. So I got approached after I finished that project with the client with 6.5 million records that had to also do real-time ranking. When all the data that's coming in is being updated, it has to real-time re-rank everything in like an index. So that was kind of challenging, and I was kind of really pushing the boundaries of what I knew how to do. And then about that same time, Oak Hill Collaborative up the street. Let's see, can we see it from here? No, we're aimed the wrong direction. It's that way, as if anyone knows where the Peanut Bridge is across the Mahoning River. If you go up the hill past the cemetery on the right, there is a building past the old Southside Hospital. It's called the Renaissance Building, where there's government services. It's called Oak Hill Collaborative, and it's a makerspace. They have a lot of people who just kind of float in and out of there, and they all have some area of expertise. Technically, there's a robotics lab. There is a general purpose computing lab where they do like educational classes for community outreach. You know, thinking about like the people who are on the south side, right? Generally lower educational attainment, lower socioeconomic levels. They need the computer skills in order to level up, right? I went in there and I said, hey, is anyone doing anything for kids? And they said no, but you know, if you'd like to take a swing at making a program like that, go ahead and do it. So I developed this curriculum for kids. We put it in the area grade schools, and you know, and this is Youngstown City that we're talking about. So maybe they don't have access to their own computer hardware, right? Maybe you know, they've never owned their own device. You know, like it's more common now for kids to own these, right? But can you really accomplish any computing with this? can you really learn anything with this other than maybe watch some Khan Academy videos, right? The answer is no. So I feel like Raspberry Pi is like the perfect fit for that. So we got some grant funding through United Way, and you know, we've put this on also for Boys and Girls Clubs and stuff like that. So that's been an ongoing process, and COVID was pretty disruptive to that. But so then I got familiar with the Raspberry Pi sort of ecosystem through that. I had never really dabbled in it. I never saw a point because I always had all this overbuilt computer hardware, and it's like, well, what do I need that for, right? Well, it turns out that there are certain problem spaces where a Raspberry Pi is the optimal solution because it's low cost, it's pretty durable, it's easy to maintain, it's low power. If power is interrupted, it can come back up. It just boots itself back up off the SD card. As long as the SD card's not corrupted, you're going to get, you know, pretty reliable operation even in some pretty rough conditions. So this guy approached me. He owns a fish farm in Palacios, Texas. In fact, I'm going to tab out of here real quick and show you what Palacios, Texas looks like. And I don't know how many of you play GeoGuessr. Anybody play GeoGuessr in here? Right? That's the ultimate game. I don't play any video games aside from that anymore because I don't really consider it a game. It's more of like this tourism app, right? For those of us who are not driving around everywhere. So if we look real closely at Palacios, Texas, and this is important because I want you to see what the problem space is.
Are you sharing your screen to the big screen?
It should be. It should be on HDMI 1, and if it's not, then it's going to be a problem.
Add a one in the background.
I think it was extended.
Yeah.
Oh, that's terrible. Yeah, because I have on my desktop at work, I have, I'll just move this, well, I want it mirrored actually, because I need to be able to see. So,
What class do you teach at HackYSU?
I teach usually freshman fundamentals of programming, so it's Python for 1595 or C++ for 2610. And I get a lot of electrical engineers actually in my 2610 class because it is a requirement. Let's see here. Of course, there. How are we doing here? Keep changes, sure.
There we go.
All right. So yeah, friends don't let friends use Microsoft, and just ignore the 100 tabs I have in the other window.
Oh, that's
Oh,
usual.
God.
That's normal.
Yeah, I always make sure, because work buys my work laptop, that I get the highest spec thing that I can. And this is like 5 years old now, but it's got 32 gigs of RAM, so it's like, yeah, just kick it around a little bit. So Palacios, Texas. Let's take a look at this place. All right, so what do we notice? We notice that there's this Turtle Bay here, right? And this empties out into, this is coastal Texas, right? So up here on the right, we have, we got the big cities of Houston is pretty close by, right? Just to give you an idea of where this is in Texas. So San Antonio, Austin, Houston. Galveston is like the largest major city that's close, right? Everybody sees that. So we're dealing with coastal Texas, and if you look at the satellite layer, we can look at this little Turtle Bay inlet. If we keep zooming in, and oh boy, is this like really green. This water is really green. Okay, so here's this thing. It says Fishville Trading Post, right? But what do we notice about all this stuff on the map? What are all these squares and rectangles? Texas Department of Parks and Wildlife. What are all these little things here? You see all these? And some of them are brown and some of them are green. And what's going on with this? Well, these are commercial fish farms, right? So the person who approached me about this is a part owner of one of these fish farms. And these are like giant ponds, like a whole acre, right? So they use the water from the river that empties out into this and divert it and fill up these ponds that are just dug. They're human constructed. You can see how symmetrical they are. Obviously, this does not occur in nature, right? But they do this for a reason. It's because you can take a drag net and you can walk it. Those little land bridges there, you can walk your drag net when the fish have reached maturity. You just walk your net from one side to the other, and then bam, you have all of them, right? And you might have to do it multiple times, but the net is tight enough that it's going to get all the adult fish once they're fully grown. So thinking about the problem space, there's a lot going on, right? So they have one concern being the overall health of the fish, right? Like they can't have suboptimal water conditions, so they have to continuously monitor that. And this guy told me that like what they do, and these dirt tracks are big enough to drive a truck through, right? So you get in your pickup truck, you go around, you got your clipboard, there's some employee there, right? And has a probe and gets out of the truck and pops the probe in the water and takes a measurement, right? Writes the values down on a clipboard. And proceeds to do this for all of these ponds in this farm, right? And so they typically have like a little shack, where they have like management. There's probably a marine biologist on staff, right? Because it's care and feeding of these fish. You got to go out, you got to feed these suckers, right? Now here's the thing, is if the water quality is bad, the fish aren't going to eat. And if they don't eat, you're throwing food in there and it's just sinking to the bottom. Well, there's another problem. And the problem of the fish not eating and maturing as quickly as they could is only the smallest part of the problem. The other problem is that uneaten food, it decays at the bottom of the pond and it upsets the nitrogen cycle, right? So it upsets the pH. It also upsets the carrying capacity of the oxygen in the water, right? So now we're starting to see, oh, this is a computer science problem, right? Because we have these variables that we have to optimize. So I became interested in this problem because it's an interesting space, and I was like, never approached, and you can see how big these things are. I mean, look at this. It just goes on and on and on. And if you can imagine, and like they've got trucks and things for, they have got to process all these fish, obviously, packaging, put them on ice. They got to, I guess whatever you'd call like cleaning a fish, it's like butchering for a fish, right? This is going to be a bigger and bigger concern as the human population grows, right? Because what are we doing? We're just ruining the environment all around us, and what are we going to do? Overfish all the waterways, So it doesn't make sense. This is the sustainable future, and I'm actually told that they can farm shrimp in large like containers. Like these, like if you were to go into a brewery or something, they have these like giant tanks, right? You can farm shrimp that way with a similar setup, where you're feeding them at regular intervals, whatever it is they eat. I don't know what shrimp eat, some sort of plankton, right? You've got to maintain a certain optimal oxygen level in the water, and the nitrogen cycle, is occurring. There's waste, right? There's a guy on YouTube, Kijani Grows, Kijani, and he has a system where there's fish that get fed, and the fish waste water goes into a aquaponics kind of bay where they grow vegetables and stuff. So like you can multi-purpose this, right? So in terms of like if we're thinking about Elon Musk and his Mars aspirations, right? How are you going to feed the people who get to Mars? Are you going to keep blasting rockets with food there? They're going to eat astronaut food and mix Tang? Do you all know what Tang is, or is that before your time? Tang, the astronauts drink, right? It's not nutritious. It's just like sugar crystals with orange flavoring. But, like you're going to have to grow your own food if we're extraplanetary. So this is of enormous importance, and I immediately, like the Gene Roddenberry future in me, like really took hold, and I was like, okay, this is sci-fi enough, I want in on this. And that's a lot of motivation level for me, because I overcommit to everything, like I try to help out anybody who asks me for it, and so, if you're contemplating taking my course, just know that I write probably the best recommendation letters of anyone on the campus, so just saying. Ryan, just won the YSU Pin Award for student leadership, and I'm going to take some of the credit for that because I wrote him a very nice recommendation letter. But please do, if you come into my class and you excel, I'm not going to hesitate to give you a recommendation. I've had several students apply for secret clearances, and so FBI agents show up in my office and ask me questions about them. It's weird, right? Because like I have never contemplated like having a top secret clearance, but hey, good for them, right? They're doing okay. Here's the play button. So anyway, that's all the background or information for the problem space. This talk is called Building Microcontroller Apps for Fun and Profit. And so what it's going to be is we're not going to deep dive too hard into the code, but I just want to show you how to generally approach a problem space with hardware if you've never used hardware, like wiring, especially like GPIO pins on a Raspberry Pi before. And how do you unpack all of it? Because it was several months of actually doing research, finding out like, all right, so what are we trying to accomplish? What's the right hardware for the task? What's the cheapest build that we can accomplish so that we can do it at scale? And what's the way that we can deploy this without having problems with, like, say, you're going to have to run AC power lines to everything you're going to do, right? Because if not, I mean, none of these sensor packages are available with battery power, right? It's just not going to work. So you've got to minimize cost in the physical hardware space, but also the infrastructure space, right? What is the cheap way to do this stuff? So what I arrived at was this Insight IG. They're in Slidell, Louisiana. So obviously it's a waterlogged place. They're in a swamp somewhere. And they're like, hey, we're concerned about water. Okay, great. Their main customers are actually things like wastewater treatment, right? Where they have to monitor all these same processes for the purpose of, hey, take this water that's like the sludge that came out of the sewer and make it something that we can put back into the waterway, right? Because you don't want that in the water table. So there are two main components to this system. One is the process transmitter PT2. We're going to see pictures of this stuff, so don't worry. This is the brain that pulls and receives the continuous data stream from the sensor. So it coordinates the activity of many of these sensor boxes. And then the sensor transmitter ST2 uses a Zigbee packet radio in a mesh topology. So if you're not familiar with what a mesh topology is, basically you have one thing that's transmitting and receiving, and then another thing that's transmitting and receiving, and let's say that the process transmitter that's the brain is over here, right? Well, the hop in between, right, it's receiving data and it's within range of this transmitter, right? Well, the next one down the line, so you can have multiple hops, right? It'll just find the shortest path along this mesh topology. So it's like a web, right? It's sort of like how the internet works, right? It's just trying to route the packets on the optimal path, right? You ever do a ping, right? You ever do trace route and find out how many hops, right? That's critical information. If you ever get into really hardcore networking, you'll find out that even ISPs kind of cheat a little. They might broadcast a route that they don't actually have because they want to carry the traffic because that's how they get money. There's also mess ups, like Border Gateway Protocol might mess up. It might say you have a route to something that you don't actually have, and you'd see like route, it's called route flapping, where the shortest path actually changes between two different things like constantly, and it creates a problem. So a lot of the, like you're online, you're trying to load a web page and it's just not working. There's a lot of technical things that can go wrong as far as routing packets go. This is really simple because Zigbee packet radio's got a pretty good range, and if you have acre ponds like we saw in that other maps display, how do you reach all those, right? You're going to put Cat5 cable down? It just doesn't make sense. You're going to put poles up? It's like, no, you're not going to do that. So using a wireless kind of transmission protocol minimizes the amount of cable that we have to lay. And so they have available dissolved oxygen and pH, the aforementioned sensors of some importance. So spoilers, I got all this stuff to work, right? It took some time to kind of figure out. So this is what my test bed kind of looked like. Here it is in a disused exercise corner of the house I was in at the time. The ST2 is the small square box right here. We can see two cables coming out. There's only one sensor in the water right this second. and then this is the process analyzer, right? So it has a monochrome LED screen, and there's some stuff in these waterproof enclosures, right? There's like a rubber gasket around this thing, because don't forget, these things have to be weatherproof, right? They're going to be outside. So here's the thing. You can walk up on this process analyzer, and you can see the data on this screen, but every time you'd want to go check it, you got to walk over to it. Now, does that sound right to you? No. I mean, we have things like the internet. We could store all the data streams that are coming in the cloud. You see where I'm going with this? Okay. So this data will actually help them optimize their processes if they can look at the big picture over a long span of time. So I was not, like crazy about the fact that at least you could real-time monitor to see whether the sensors were giving reliable input, right? And you can see that it says channel 1 in the top right corner, and then here's your temperature and dissolved oxygen. That's the sensor that's in there right now, right? And it's giving you some real-time diagnostics about the amperage that's going through the sensor. So set point relay is your ability to turn a switch. A relay is like a switch, right? You can turn it on or off based on some threshold value. So let's say the dissolved oxygen gets less than 7 parts per million. Well, then we can turn the relay on, and you can just set this up right here in this hardware box. You don't need software or any kind of microcontroller to do that. But you can scroll through the menus, and you can set it up in the setup menu, and you can say, well, make the relay turn on a motor with a paddle wheel. And well, how do you increase the oxygen in a pond? They have like a paddle wheel like on a paddle boat, right? And it just kind of stirs up, churns up the water, and it increases the oxygen. Because you're not going to have the little diver guy with the treasure chest, like in an aquarium at home. That's just not how you do it, right? You can have a bubbler at the bottom, but it's not going to be as efficient. It's just splashing around. Some people put up fountains, but the thing is that thing has to run continuously, right? Well, not really if you have it on a relay. So clean relay, this is for another kind of approach for cleaning the sensor itself, right? Because the sensor itself for dissolved oxygen is sort of like this little light-based thing. It measures the light that's coming in. It does some sort of refraction thing. Hey, look, I never took lab sciences as an undergrad, right? I got by without taking chemistry one time, not even once. So I don't know anything about I'm looking at this problem space so naively. I know what it is, I just don't know how it's done. But the thing is I don't have to care because somebody made me that sensor, right? I know that it can't get dirty, and I know that you can have some sort of water jet thing that can shoot it when you can clean the relays remotely, right? So that's a useful thing, right? That's another process that we can automate, that they don't have to go out, physically grab up the sensor, clean it off, throw it back in, right? You can just leave it there. And in fact, I had suggested that they drive a post into the ground and then sort of have an arm and hang it off suspended so that it's a constant depth, because if it's suspended by, you can see the suspension by the sensor wire is not a big deal. And this is an outdoor pond. Of course it's going to get dirty, right? You got fish waste in there. You got the dirt that gets kicked up when they swim around and stuff. If there's a storm, right? If there's a storm, you got to worry about the oxygen level because it churns there's a gradient of where the oxygen is in the layers of the water depending on the depth. And so when the storm happens, that's when you see fish kills. So if you go to a park or something, you ever see a bunch of dead fish along the shore? It's because of a storm or some sort of event that displaced enough water that it was a problem. And of course, you don't want your entire fish harvest to die because of that stuff. So that's even more important to have accurate readings from this DO meter. So these are the two sensor probes, ST2 and DO. And you can see there's like a little lens right here. It's an optical sensor. So that's how they do the dissolved oxygen. Now pH, there's like some sort of sampling chamber or something where it goes in and it has, it applies, I think, a current to it. I think that's how that works. I don't know. I'm not a chemist, right? I'm a nerd who likes to get these things wired together. So the first thing I had to do was, okay, power to these things, right? It's a little scary at first. You know, you're dealing with AC power. It's like, oh, here's this thing with the plug on the end, and here's bare wire ends. Do it, right? So rule number one is don't have it plugged into anything while you're working on it, right? So there's a standoff inside of this chassis. You can see there's a rubber gasket, and here it says 115 volts AC. That's North America standard, right? So you got hot, cold, and ground, right? And it's labeled. It's clearly labeled because the ground is the center one. You can see the symbol for it. And then so hot and cold, black, white. And now we got to deal with how do we get the data from the process analyzer to the Raspberry Pi. That's the focus of this talk, right? That's like where the actual rubber hits the road. It's only a 2-wire protocol, right? Modbus is in a lot of industrial automation. It's a 2-wire protocol. It's RS-422. And because it's like a regular serial communication, you can use a lot of different connectors for it. You can use the pins on a RS-232 like the old school mouse, you know, like the trapezoid with the pins in. That's a lot of BS, so I don't deal with that, right? I just use plain old Cat5 cable, and I exposed 2 wires and a ground, right? You can see I have the brown wire. I decided to use the brown wire from Cat5 for the ground, so that one's sticking out because I don't have that wired in yet. I just wanted to clearly show I've got blue and blue-white for positive, negative. And so RS-422 should be twisted pair because you get a lot of interference when it's not, and that's the whole reason why Ethernet cable is twisted, right? There's usually like a core on the inside, and it keeps the different pairs separated, but they're twisted the whole way down. So I just stripped off Cat5, and how does this protocol work? Well, what it does is it alternates applying voltage to one or the other cable, right? So when, you know, like you can see the ones here, there's voltage applied to the positive and no voltage applied to the negative, and then they just switch, right? So all you have to do to read these bits, and you know, there's a timing interval involved, but that's what they make libraries for, right? So we're not going to try to write this from scratch. If we had to go into C++ and write some kind of weird driver for it, no, we're not going to do that. All right, so in the sensor boxes, and note that there are these weatherproof kind of fittings on here, right? They just have these knockout little, you know, like where it's perforated, and you just take a screwdriver and just bash it out, and then you have to get these, right? So this didn't come with it. I had to figure out, like, oh, well, it needs to be weatherproof, and you can't have things like, even though it's going to be vertical, right? And this is on the bottom, you still don't want, you know, in inclement weather, you don't want any moisture coming in, because look, it's just a bare PCB, right? This will corrode and die faster than you can, you know, I'd say probably 6 months in the weather that they get in the Gulf Coast, this thing would be dead. So you have to have these, there's no way around it. And you can see the amount of rubber shielding around the wires here. So this is the relay standoff that I mentioned. So you can actually have a relay, and you'll have to step this voltage up to actually power like a motor for like a paddle wheel or something, right? It has to go to another relay that can step up voltage. But you've got separate standoff on here for here's RS-485, but here's the sensor lead, right? And you don't need this because you're not going to wire this into anything. The option is there, right? You could just take this and like put it through the empty space here. But I didn't want it to be wired. I wanted it to use the radio, which you can sort of see up here. You can definitely see it right here. It says RF engine, right? So this is the synapsewireless.com. It looks like a hyphen in between. This is who makes the radio controller, and you can see they just made that so that it was like an add-on board that could snap into this thing. And there's, hey, look, there's a, you know, RS-232 connector for people who want to connect to it like that. And then these are knobs that sets the sensor address. It's one of 16 values, right? Geez, I wonder why they chose 16, you know, something binary, right? And this is where the sensor actually gets hooked in, and you just have to, it's labeled clearly red, green, white, black, shield, right? So there's a ground wire to this. So that's the inside of these boxes. It was pretty simple to set up. All you had to do was RTFM, you know that phrase, RTFM? Read the effing manual. So here's the real problem, right? Raspberry Pi has these GPIO headers, and they will actually do everything you need them to do. But you'll drive yourself crazy, right? Putting these little, you know, like you get these little patch cables and you just, right? No, the answer was no. So my first attempt, I wired it like this, and then you're reading the raw GPIO pins, and you have to use like a C library for that. I was like, yeah, I don't know. This looks like there's a lot of things that can go wrong. I mean, there's a lot of good things about this. A lot of the Raspberry Pi add-on shields that you can put on it just snap right onto the GPIO header. So it enables you to do things like you want to drive a display, or you want to put some controller ports on it, or something that is non-standard, right? It has all of these communication protocols available to you, SPI, I2C, UART, and then there's a power port, right? So you have to know, like, okay, which one of these have active voltage going through it, that it's designed for a thing, which one's in the ground, and even the pin numbering, right? If we look at the Wiring Pi library, the GPIO pins are numbered differently than the numbers of the pin itself. 1, 2, 3, 4, 5, 6, right, is how they're numbering it here. And these are the actual pins when you're pulling the GPIO pins. So there's an extra level of confusion there that you could really fall into. It clearly marks, you know, these are the ones with the voltages, these are the grounds. That's nice and helpful and fun. I didn't want to deal with that. So you're thinking, well, if you didn't want to deal with that, what the heck did you do? So I found a USB to RS-485 / RS-422 converter. And it's real simple, just pops right into the USB port. And there's a Linux driver for it. So you can just read it off of there. And this is just, you know, I found it on Amazon, but I'm sure that, who's the big electrical supply, the doodads? I can't even remember, it's been so long. Like anybody who carries these kind of widgets and little electrical products is going to have this thing. It's just supply chain problems nowadays, right? In our post-COVID world, we got all these cargo containers parked off of the port of LA, and they can't even unload them fast enough. So anyway, you just kind of reference, and you can see here clearly the blue-white combo that I had and the ground wire. You just have to know which one to put them in, right? So they're numbered, right? What could be easier? So positive, negative, and ground right there. Pop it on. Now all we need is software to read this thing. So I found a library. Let's pull this up. Pull it up, Jamie. So this gentleman here, you know, despite his interest in coffee and horses, does a lot of code projects, and let's see here. He wrote this GPIO library, and it handles all this stuff, right? Now you can get all of the same information via USB from that widget, and so this library exists out there, and it's written in C. So if it's written in C, how many languages do you think can use this thing? Well, the answer is all of them, right? Most interpreted languages are built on C or C++. And just about every other language has some way for you to call function libraries from a different language, right? Now in Microsoft parlance, you build DLLs for that, and you know, that's what allows you to use all these different like Win32 libraries are written in C++, and you can call from Visual Basic, you can call Win32 libraries and do things that C++ could do, right? So you're not limited to any specific language. I just wanted to show you that, because it's like, well, I choose my favorite language, and I always try to choose my favorite language from the list of options based on how suitable it is for the project. And for this project, because it's going to involve the cloud, it's going to involve having a web UI, right? Because the idea, the end point is not just to collect the data and shoot it up in the cloud, but remember that marine biologist in the shack? Well, instead of this guy jumping into his truck and popping this probe in the thing and writing down on his little clipboard and then analyzing the data later, how about just give him an iPad, right? How about just have blanket Wi-Fi coverage on this whole several acre farm? And you could do that with a Yagi directional antenna, right? I made one out of a stew can, 18.5-ounce stew can from Walmart. The stew was not the greatest, not even mildly delicious, but the can dimensions, the geometry of it was a perfect waveguide. And I was able to penetrate 3 brick walls 200 yards away, right, to get to my neighbor's Wi-Fi router. So I'd say that's pretty effective. And you know, and when you don't have anything, you know, just when you're a broke student, the greatest thing, the greatest gift that you have is that like you can't just throw money at a problem. So you have to understand how the stuff works. So if you can understand how the stuff works, you can just sort of hack your way to a solution. So there is a calculator online that you can find out exactly what distance, what dimensions of can and what distance from the end of the can do you poke a hole. I just stripped some coax cable that I had laying around, jammed the bare copper up there, right? Took the other side, duct tape it to the end of a network card, set that old rotten PC up to be just to run Linux and run IP tables. That became my gateway. And then I just plugged that into a switch, and then I had internet in my shack that I lived in. Right? When I came back from grad school, I was dead broke and helping my one buddy fix up his shack in his backyard to make it habitable. Right? So I had to redo a bathroom, and so you learn all kinds of skills, right? When you don't have anything, it's like, oh, now I know how to hang drywall, right? This is no different. So I learned how to do that, and it sort of fed into this other problem space. It's like, well, give the guy an iPad. You know, you could buy an iPad mini, the little tiny thing, and you could pull up the web interface, and you could see real-time graphs update for each and every pond. And you could actually have a menu-driven system where you could select the pond that you're at, and you could see the data and say, oh, well, this is fine, or it's not fine, and I need to investigate. And you could sit on your tuchus in the shack and just, you know, where there's air conditioning, because it's hot down there, right? Do you want to be in the hot, beating sun all day? No, you don't. So I chose Ruby because they had a gem available for this, and it does a lot of internet-y things that are good. So if you've never seen the gem ecosystem before, the libraries that you can add on to the base, you know, Ruby functionality, all you have to do is from the console say gem install and then the name of the gem. If you search for keywords, it'll give you whatever you want. You know, we're all standing on the shoulders of giants. Don't reinvent the wheel, right? If someone wrote a library that works and it's well reviewed, look at the total downloads, 26,962. So there's a lot of hobbyists using this Ruby gem to get that kind of communication. So it includes GPIO, I2C, SPI, serial, shift in, shift out, and credit to Gordon for the wiring Pi library, right? So that's what we just looked at, the gentleman with the horse and the coffee. So download this, read the docs, right? You got to read the docs. And so from the gem page, the docs are always here. There's usually a home page, but sometimes not. And here's the docs. When you install gems, you get documentation generated for you. You just have to know how to read it from the console. So it's sort of like Linux man pages. You ever use Linux man pages? Man and then the name of the command. Well, it's sort of like that for the gem ecosystem. So the person who wrote this, they're hosting this website on a Raspberry Pi, right? Ordinarily, it says temporarily not on a Pi. I don't know what happened, but you can host websites on a Raspberry Pi, right? So if you need another incentive to crack that thing out of the box, you know, I'm looking at you. You can host websites. It's real easy to do your own DNS if you use AWS Route 53. The docs are pretty good. You learn all about DNS records and how those work. You go and register a domain, and then you just have it point to your IP address. In fact, there's a script that I have in my GitHub, and you can have it. Let's see if I log in. I can just go to my, where's my repos? All right, so this Route 53 dynamic DNS Ruby script, right? It has minimal docs here that you can just see how to do it, and you can set it up as a Linux cron job. So every 5 minutes, it can check to see whether its IP changed. Just look at the Ethernet interface and say, did it change? If not, don't do anything, right? If it changed, then you can just push that change up to Route 53, and it will, because not everybody's ISP is good about keeping the same IP address unless you pay, right? Anyway, this is my GitHub repository. There's not a whole lot here because I've written a lot of proprietary code for people. So yeah, no activity. I'm too busy at work to do anything with this. But I think this Route 53 script is useful enough that you might want to know about it. So anyway, yeah, my GitHub is JDITTRIC. Check that out if you want to run services at home. You'll probably also have to configure your router at home, and I recommend ASUS. They seem to be like the easiest one to configure with complex like IP pass-throughs and stuff. You'll want to forward all of the port 80 traffic if you're trying to do web stuff, and 443 for secure HTTPS to a specific machine based on whatever IP you give it. So always set a static IP address in the machine that you're hosting your web services from. So anyway, this person puts some like real simple tutorial code, and it doesn't really get you very far if you don't know what they're talking about, right? So I have some example code. If I can just pull it up out of Drive. When we get there, I might have something. Okay, so what's the other good reason why we use a Raspberry Pi? Is you can SSH to it. And if you have a static IP and you forward port 22 from your router from a dynamic DNS, you can always reach it from anywhere. And so what I could do then is I could demo this code live with this thing hooked up to the Raspberry Pi from anywhere in the world, which was kind of cool, right? So I just SSH into whatever it is IP, and you can see in this picture it's the local address 192.168.1, and then I gave it 123 because it was easy to remember. But here I have the interactive Ruby console in the right-hand side, and you can see I'm actively polling the sensors based on their addresses, and then I've got a formula here to calculate what the temperature in Fahrenheit ought to be. So I have to do 32 plus 0.18 because it's Celsius. I've got to do the conversion, and then it shows me the floating point number, right? And then I added some formatting later on down the line. If you use \x B0, it looks like that's the degree marker. So it shows the temperature both in Celsius and Fahrenheit because we're the only country in the world that uses the dumb system, right? So everyone wants to see degrees centigrade and not Fahrenheit. So anyway, another good thing about Ruby is because it's an interpreted language, you can just run a service and it's running in Ruby and it just does the thing, or you can just pull up the interpreter and you can test out your code, right? So if you're going to do rapid prototyping, it's super fun to kind of work out like, okay, what does this code statement need to do? Get this code statement right, find out that the output is correct, and now copy paste into your source file. And yeah, this is in fact a Windows SSH. So I had to PSA it. Friends do not let friends use Microsoft, and I was demoing on someone else's machine, right? Because God forbid I touch that stuff. It's bad. This is the process analyzer display. So this is what you can be shown. So the idea is we're going to put this unit in the shack. It's going to be at a fixed position, and it's going to have enough range to get to those first two sensor mesh nodes, right? And every single one from that point on is within range of another node, so it just kind of hop all the way. And you can have up to 16 channels, right? We saw the little selector kind of switch in there. once you select it and then you seal it up and you just throw it out there, then it transmits on that frequency that it's set to receive at, and you can see the real-time data just populate this. So you can toggle between these 4 displays. You can have 8 at a time, 2 at a time, 16 at a time, or 1 with a graph. So that's kind of cool. And you can see temperature and dissolved oxygen there. Now, if you wanted to do pH and dissolved oxygen, then you're going to need 2 of those boxes, right? And just wash, rinse, and repeat. So what that does then is it halves it. You can only have 8 different, because it's 2 channels per, right? So that's okay. Code example time, right? This is the fun part. Now, obviously, I don't have this hardware with me, right? For many reasons. Let's just see what I got here. There's a whole lot of stuff in here. Hackathon, boom. All right, so here's a scheduler example. Let's see if we can we just preview this? No preview. Got to download. Okay, fine. I should have downloaded this, but I didn't have my work laptop while I was doing the slides. It's dangerous. If it's code, it's always dangerous, right? We live on the edge. We live for the danger. I'm going to get all these .rb files.
While you're pulling those down, I just wanted to say that Joe's talked to us to get on at 3.
Okay.
I talked to him. He said that I think 3:30 is fine if you need.
Oh no, I'm wrapping it up. I'm wrapping it up. We're gonna.
Well,
do
you
this
have
fast.
you have the time regardless because he canceled his Styles talk and is moving up React.
Oh
so
wow.
Like, you have the time.
Okay, thanks
Just
for
wanted to throw it out
the
there.
warning.
Of course.
Is everyone having fun? Because I'll continue as long as I need to.
I'll be back shortly.
All right, thank you. So, no, I don't want to download updates. Where did I put these things? Up here. Boy, is this really small in 4K. I usually have my display scale, like my eyes are too old. Enjoy your vision while you can. It goes. Can I please? Yes, I use Ruby every day. It's my preferred language. Can I just please drag and drop? Will it let me? No. Why not? Okay, file, open. We'll do what you say. All right, so this stuff actually gets pretty simple. This example just shows you about the Raspberry Pi pins versus the RS-485 pins, because they're labeled differently. Engineers, they write the worst docs, period, right? It's like hardly intelligible. So the more documentations you get, like software is definitely better documented than hardware, in my opinion. And it assumes a lot, right? Anytime you're looking at hardware docs, it assumes a lot. So this just shows you just a real simple how to read, and what pin number you're reading from and what it's trying to do. And then this is how you set up serial communication. You have a Linux dev / whatever that port is supposed to be. And then this is the transmission rate, 9600 baud. You don't need to go hyper fast. In fact, a lot of sensors and a lot of these transmission protocols are so old that if you try to push it to a really fast baud rate, it'll glitch out on you. So you definitely don't want to do that. So there's that example. Let me pop this. Can everyone read this? Is this big enough on this monitor? Can I please get this to be bigger? And I hate touchpads, by the way, so I'm going to screw this up. You can't tell me that that's the base zoom level. You can do it. View. Oh, come on. I don't ever have to do this because my resolution is so low on all my monitors. macro size, though. There's got to be a zoomer in here. Font, oh, I'll just larger. Control plus equals, that's why. I'm hitting Control plus. Okay.
That would make sense.
Yeah, super easy, simple. So doing measurements, I'm giving it a path to a CSV to write to, and look at how easy CSV writing is in Ruby, right? We just give it a path to a file, and then we just append, right? We're redirecting this input. I'm going to have an array of values. It's going to be the now time, and then the sensor, which I have mapped from this library right here. So I'll just put these things in an array, and it'll write the next line. And because it's CSV, some bonehead could open up Excel, right? Because most people don't know that a CSV is just a readable file. You can just throw it in a text editor, and it's right there. It's comma separated, and the different records are just separated with the new line character. So that's a really nice data interchange format. Now you can get fancier. Obviously, the net goal of this thing was to write JSON format, right? So that we could just push that into the Couchbase database because it's documented oriented. The format of it is a JSON key value store, right? So the unique ID of the record is actually the key of the document, and then the value is the body, and then all the attributes you want in the models that you're going to do if you do object-oriented stuff is in the body of that document. So CSV, quick and dirty, right? You can see how you start getting stuff. So another thing I wanted to mention is this awesome print library. If you want to do debugging, no matter what kind of data structure you're using, whether it's like a nested structure, arrays, hashes, you got arrays on the value side of the hash, you got a hash nested inside another hash, it doesn't matter, it'll print it out, and it's very pretty printing, so that's something to take note of. If you need to open URLs and parse documents, OpenURI is something you're going to want to use, and that just allows you to initiate a web connection over whatever the regular web ports are. And then Nokogiri is a document parser, right? So it can parse XML, it can parse HTML5, it can parse a whole bunch of terrible and terrifying documents. Instead of writing your own string tokenizer and parsing out all the data, just use that, and it's much better. You can even use CSS selectors. You can use XPath selectors. Really good stuff. So here's an example of polling on a schedule, right? So I've got every 60 seconds due, right? And this is all you need in the Ruby library to actually make this occur. And it doesn't require you to write a complex cron job and call a script every time you want to do this. You just set up a loop, and it'll just loop this until it loses power or the hardware dies, right? So I think this is a pretty elegant solution. Look at how low code this is. So it's putting the data points in there with do row, comma, I, points, and then boom. Oh, there's a typo in here, points. So this is just for me to create like XY coordinate points for graphing. So anyway, super low code. There was one other, wasn't there? There were three. I got them all. Anyway, they're super low code. I obviously can't show you the production code because it was a commercial project, but I think I've got you pointed in the right direction. What other fun things? I don't think I have many slides left. Oh yeah, this is the end. Anyway, special thanks to Ryan, Sam, Dee, Tyler to put this on. They do a great job of making this happen each and every year, and I'm grateful for the opportunity to speak to all of you. Question and answer time. Anything you want to know about any of the components of that system? How many people are going to run out and buy a Raspberry Pi now if you don't have one already? I'm a good salesman for it, right? It does a lot of things. The fact that it can host, if you wanted to have a web presentation layer of the data, you don't even need anything that scales. You can have something like SQLite. You can just toss it in with just generic SQL statements, and then when it's time to write the data out, boom, you know. D3.js, I highly recommend learning if you want to do charting in JavaScript front end. If you look at the guys' examples, like the chart types are off the wall. They're incredible. They've got everything, really. D3.js. Why didn't it go to the Google search page? There we go. Oh, they have an what? That's not. Oh, I typed it wrong. That's why. Here we go. How many people have seen this before? D3.js. Okay, this is something you absolutely have to look at because it is so cool. If we look, this whole grid right here is links to examples, right? So you can see these chart types. They're amazing. And they've got like map projections and all kinds of stuff. They've connections of graphs. Where is the come on? Oh, they've got a commercial service now. That was his end game. This Mike Bostock, who created this, really just hit it out of the park. I want to find a really fun, cool examples. Okay, so you go to examples, and here's the gallery, and every chart type that you could ever think of is already represented here. And all you have to do is figure out how to work the code example to get it to do the thing you want. Big data people, scatter plots are huge for that. So it shows you how to lay out a scatter plot on a graph. Let's see here. There's tons of these things. Zoomable charts, right? You got a zoomable area, right? So how do they do that? Look at that, isn't that cool? And then the axes scale along with it. So I've done some stuff for people with stocks using this kind of idea, and you know, and these are like really simple data points. But election night stuff, that's called a choropleth. He's got one of those. Yeah, so if you wanted to represent your data in any possible way, radial stacked bar chart. I mean, like you can go through Excel and you can try to find the wizards to get you these things. These charts are way cooler, and the sooner you learn a little bit of JavaScript, you know, the deadlier you become. This is a election night staple, right? And we always see like red, blue, right? It's called a choropleth. He shows you how to set this up. Look at how low code this is, right? And this is a one-axis chart. This is just representing unemployment data. And it loads this stuff in from, it should show you. It's very easy to load it either from a RESTful endpoint with JSON at the endpoint, or to open up like a tab separated or comma separated file. Yeah, we don't use automatic type inference for CSV. So here it is. This one line of code gets you the entire data set, and that's how you reference that. So if you want to get into any one of these examples, they've got links that take you down the rabbit hole. I highly recommend. This is the end goal for this project, is to be dynamic and zoomable graphs. You had a question? No?
No.
Okay. Anybody? I will probably make these slides public at some point, you know, and I'll probably put them on my website. My very massively impressive website here at YSU is jwdietrich@people.ysu.edu, and that's with my full name. I might have somebody put that on the HackYSU website or throw it in the Discord. Is everybody in the Discord? The Youngstown State Computer Club Discord? That's a great way to exchange information. Why is this not loading? I don't know. Great. Cool. Yeah, I assure you that that works. because that's where all my class information stuff is. So yeah, and if you want a sneak preview of what my classes are about, those are up there too. I don't know why this is not loading.
What is the website
It's
URL?
jwdittrich.people.ysu.edu. Let's find out. Did I lose my? No, I didn't lose my
I think
connection.
it's something with the event.
The way that they're routing packets.
Yeah, I can't get onto Blackboard.
Okay, so campus endpoints are not available through this event Wi-Fi. How nice.
I got it through my mobile.
Okay, you got it through the mobile. You see that it's a place. I'll drop the slides in there. I'll also drop them in the Discord maybe, or at least the URL to them. Fair enough. If you have any questions, and throughout the day I'll be here. If you're trying to make something cool happen, I'm more than happy to ask me anything. Okay? Thanks.